Okay, hello everybody and welcome to this week's Geo lecture. I'm delighted to say that we're joined this week by Dr. Simon Carr from the University of Cumbria, who's going to be talking about geomorphology and in the Anthropocene. Just a couple of words from me before we get going. If you do have any comments or questions that you'd like to leave for Simon during the session, please do so in the chat box on the right-hand side, and we'll pick up on those at the end. Thanks to everybody that signed up for this event. If you'd like to sign up for some more upcoming Geo lectures and tutorials, please go to the live event section on the Geo website and you can find all the ones that are coming up. The full replay of this stream will be available on the site tomorrow. You can go and watch that on YouTube at any point in the future. And we will also upload the PowerPoint from this session, so you can download that at a later date. Yeah, I think that's everything from me. So I will hand over to Simon now.
Brilliant. Thank you very much, Aaron. Good to see you all this afternoon. I think we've got a good turnout for this afternoon session. Hopefully, the photo here really distills what I'm hoping to be talking about today, which is the role that landscape plays within this emerging context of the Anthropocene. And really, the reason for coming into this talk is, for me, geomorphology has always occupied a major place in the teaching of geography. In many ways, people view geomorphology as one of the three core strands of physical geography, with biogeography and with the examination of environmental change. But I can't help thinking the subject doesn't feel like it's moved with the times. It still feels like we're not really seeing the drama and the excitement comes out from looking at our physical environment being taught, particularly in that transition between school and university. And certainly one of my experiences that other sort of maybe let's call them more fashionable subject areas within geography have started to gain a lot of popularity, often at the expense of geomorphology. And I think that's a real shame, because I think that geomorphology is absolutely central to so many of the grand challenges that humanity is going to be facing and the planet is going to be facing over the coming decades and centuries. And I was quite struck when I was preparing this session. I was looking at the QAA, I was looking at Ofsted and Ofqual, the various frameworks that define geography in the UK, and just searching for where the term geomorphology comes up in those specifications, and it's disappearing from those areas, which I think is a real shame in terms of our understanding of the subject. So for those of you that aren't necessarily familiar with the terminology, geomorphology, we can break it down into its Latin and Greek origins as being essentially the study of the processes that shape the Earth's surface. And we can see in landscapes, such as the Central Lake District, we can see and read the landscape in terms of the processes that have shaped that over time. So we have, in this image, we've got weathering processes, hill slope, fluvial processes, which are modifying and reworking a relict landscape of past glaciation in the Central Lakes. So let's start off with thinking about, first of all, what I suppose the traditional view of geomorphology is. And I'm going to start off by talking about probably one of the leading geomorphologists of the late 20th century, a man called Dennis Brunsden, you can see here in the photograph. Now, he was a top geomorphologist based in a variety of universities, primarily King's College in London. And he was someone who was trying to explore, how do we make a landscape? And he published a paper, a real signature paper in 1990, which was called The Tablets of Stone, the 10 Commandments of Geomorphology. And in this, what he was trying to do was he was trying to distill our understanding of how the physical landscape is shaped. Now, the reason for talking about this paper is that in many ways, it absolutely defines to the present day how we teach about Earth surface processes within school and to a certain extent within university education. And broadly speaking, Dennis Brunsden, who's from the southwest of England, so he based his paper on this walk he did over Buckland Beacon in Dartmoor, where there is the famous 10 Commandments stone, the carving of the 10 Commandments on the summit of this tour. And he was thinking, well, there should be similar commandments for how landscapes are produced. And he came out with three broad sections of his ideas, that the landscapes were defined by plate tectonics, they were defined by the role of climate and climate change, and then they were also defined by something that was a little bit more woolly in his sort of terminology, which was how landscapes change and how sensitive they are to being perturbed and disturbed. I'm not going to look at these concepts in any great detail. We're just going to flash through his 10 commandments, but hopefully as we go through them, you'll find that most of the themes that we refer to here seem to be broadly familiar. And certainly those of you that are doing geography at school at the moment or at university, you'll probably go, oh yeah, I've seen that. We've studied that element within there. So he starts off with his first two, what he thinks of as his most important commandments. That first of all, that the structure of the planet, the distribution of land and ocean, the location of mountainous regions, the location of tectonically and volcanically active sites is driven by this global plate tectonic processes. That those processes have shaped and drifted our continental plates around, they've created mountain zones, they've uplifted landscapes way above sea level. And then superimposed upon that, we then have the role of how that uplift creates the processes that wear down the landscape, the processes that we call denudation. And so the higher the uplift, the more effective gravity becomes at dragging everything down and driving the processes that erode and wear down that landscape, what we refer to as the processes of denudation. So then the three sort of next commandments that Dennis Brunsden came out with talked about the role of climate and the role that those denudation processes that we talked about will shape landscapes down to what we refer to as base level. In most cases, that would be sea level, global sea level, or it could be a more local base level defined by, say, a large lake basin. But what we tend to see is that those processes that shape our landscape will denude the landscape down to sea level and then deposit sediments within our shallow continental seas. And that superimposed upon that, those denudation processes will be driven by climate. That the climatic conditions, so the effectiveness of physical and chemical weathering, the way that water or snow is supplied to the landscape, the rate at which that is supplied, all of those processes will drive the mechanisms that shape the physical landscape. And that operating under gravity, that gravitational forcing will encourage those materials to move down slope, whether it's through gravity, water, air or ice, down to eventually a base level, a sea level. So that he derived this idea of what we call climatic geomorphology, and we can look across the surface of planet Earth and we can read the landscape and say, well, the climate of this area is shaping the processes that we see in the present day. We could also see in places like the British Isles the past climate record in terms of the record of things like past glacial or periglacial processes. And that leads us to the fifth premise that Dennis Brunsden came out with, which was this idea that climate changes, climate isn't static. As you can see from that image on the top right there, taken from the Vostok ice core, a record of 420,000 years of climate change from East Antarctica, we can see that the stability that we've seen in our recent climate, which is the area that's sort of picked out with the red box on the right-hand side of the graph, is very much an anomaly compared to what's happened over the last best part of 500,000 years. So that as that climate has varied at a global level down to a local level, that has also modified those processes that shape and denude the landscape. And of course, changes in sea level. When we get global glaciation, we see sea level decline, which invigorates and creates greater gravitational stress to shape that landscape. Then the final set of Dennis Brunsden's commandments all focus on how do we change a landscape? How do we modify a landscape? And the basis of this is something that we see across our understanding, particularly in physical geography, of what we call process-form relationships. You'll often see in textbooks of the physical structure of the planet, you'll see these diagrams like the shaping of a roche moutonne underneath a glacier, showing how we can look at the relationship between the processes operating that shape a particular landform. But then we also have to recognize that those landforms aren't being continuously produced. Dennis Brunsden talks about the idea of what we call episodic process events, an individual storm that will cause a landslide to occur, or a flood event that will change the behaviour of a stream system, or that perhaps we can get really large-scale events such as the breaking open of the Straits of Gibraltar, flooding the Mediterranean basin, which cause catastrophic changes to the way that the Earth system functions, what we refer to as geocatastrophes. And then Dennis Brunsden talks a lot about the idea of landscape stability and sensitivity, particularly recognising, and you can see this in the example of the Grand Canyon up there in the top of the slide, the idea that old landscapes seem to be much, much more resilient to change. Here we've got the example of the Colorado River punching its way through the sandstones in the central part of Nevada and Arizona, creating this river valley system which has been in operation for millions of years. Yet if you look outside today, it's raining here in Cumbria, as it always tends to be, but you look outside today, you can also see ephemeral processes that are taking place and being reworked and instantly. Go down to the beach and look at sand grains being moved around by every single individual wave. It's this idea that we see persistence and resilience building within our landscape. So hopefully those 10 commandments, maybe you haven't sort of heard them in that sort of format, that sort of codified system that Dennis Brunsden came out with, but hopefully you can see how those concepts that Dennis Brunsden identified back in the 1980s and early 1990s are probably quite familiar. They explain a lot of how we understand geomorphology. But I think it's a shame when you look at geomorphology as a subject, actually what is missing. This is just a word cloud I generated just from the Wikipedia page on geomorphology just the other day. And, you know, it's really interesting. You look at that, you see rivers, glaciers, sediment, processes, flow, hill slopes. There's lots of really, words that are very familiar to you as you look at that. But what's interesting is what's missing from those words. If I look at that, we look at the definition of geomorphology, taken in this case from Wikipedia yesterday. We look at that definition, and I think that's telling us something that's really out of date. It's missing two key things that I think are missing from our landscape. And it's a shame, because what we talk about is, we do talk about the things that are missing here, but we don't talk about them in the context of geomorphology. And that comes down to some of the areas that I believe that sort of gets missed out a little bit within that sort of codification of landscape that Dennis Brunsden came out with. We think about landscape here in the central Lake District here. This landscape is what we refer to as a palimpsest. There's a whole series of different layers superimposed one on top of each other. We've got a complex suite of multiple landscapes. As you can see, we've got the physical landscape here. We've got the physical first order processes which are driven by physics. In this case, you can see Brothers Water in the background feeding the Goldrill Beck that feeds down into Patterdale here in the central Lake District. And there are slope processes taking place, but there's also the relics landscape of past glaciation here that we can see. But superimposed on top of that, we've then got a biological landscape. There's the vegetation structure. What does that vegetation, how does that biosphere shape our landscapes? In fact, something we'll come back to a little bit later on in this session is the idea that actually this landscape of the Lake District that you can see here, in many ways is completely unnatural. And then we have superimposed on top of the biological landscape, we have this idea of the cultural landscape. How have humans shaped and worked within this particular environment? And I was thinking when I was preparing this session, I was looking back at some of the books that I used when I was at school and going into university about how we could understand the layers of a landscape. And I've got a really nice sort of quote that comes from Andrew Gowdy's books on humans and environmental change, which talks about the physical landscape is the basic entity that life is superimposed upon. And what Gowdy was sort of saying back then was that, we have this physical landscape and everything else is kind of overprinted on that surface. But I don't think that's necessarily the case. And hopefully, as we go through this particular session, you'll see why I feel that that's maybe no longer so appropriate. Because something that Dennis Brunsden's 10 Commandments don't refer to is that biological landscape. And since the 1970s, there's been a growth in our understanding and our study of the links between the biotic processes and the abiotic processes that shape our planet. If we think about the relationships that we see between vegetation and landscape, we can maybe understand it through this little schematic diagram, which has come from a fabulous review paper that Heather Viles from the University of Oxford published late last year, which is just looking at the history of this subject that she calls biogeomorphology. It's this idea showing the importance of vegetation. If you look at that diagram, the top panel just shows an idea of climate changing. Climate changes in this idealized world between arid and a humid state. So we've got a period with relatively little rainfall and a period with relatively high levels of rainfall. That rainfall conditions the presence of vegetation. That when we go into the more humid conditions, we will get a growth in the amount of vegetation that covers our landscape. But equally, that rainfall has also got potential to create runoff, that to create the rills, the gullies, the slope movement that starts moving sediment down slope. But of course, as vegetation grows, that vegetation will start inhibiting that level of runoff. It will start intercepting and changing catchment hydrology. So what we see at the bottom line is a reflection of the geomorphology of a particular location. We're looking here at the rate of denudation, how much sediment is being eroded, transported and deposited from our schematic catchment here. And I think it gives a really, really nice example of just how biology and geomorphology, the ecology and the biosphere, has such huge reciprocal influence over the landscape itself. And it leads people like Heather Viles to talk about this idea of saying, well, how does the ecology and the geomorphology of a landscape actually interact? Is there a signature that we can record in the landscape of life? That's particularly important when you think of, at the moment, we've just had the landing of the latest NASA rover on Mars, the Perseverance rover, which is looking for life. It's also looking, one of the experiments it's looking for is saying, well, can we see in the landscape evidence for life that is recorded in the processes which have shaped the geomorphology of Mars? So we can see how some of these ideas start building into very, very contemporary ideas of how life and landscape co-evolve. We can see the role that vegetation plays. In an example, here's some work that I've been involved in, the NERC Resist project, which is just coming to a conclusion at the moment, where a team of us have been studying salt marshes around the UK coast. Now, I don't know whether you're aware, but salt marshes have recently become extremely valuable because they are free sea defences. Salt marshes naturally accrete sediments so that they keep pace with sea level rise. So in the context of sea level change, subject we'll come back to in a few minutes, in the context of sea level change, salt marshes, essentially, they will accrete sediments and they continue to be a buffer against sea level rise. But of course, with climate change, we're also seeing an increase in the UK of extreme storm events. Certainly here up in Cumbria, we're seeing a lot of those short-term episodic high magnitude events like Storm Desmond in 2015, Storm Kira and Storm Dennis last year have had quite dramatic impacts on our local landscape, these specific process events that take place. And when we have those episodic events, we're finding that some salt marshes, such as the one that you can see in the top right here at Wharton on the east side of Morecambe Bay, have experienced dramatic coastal retreat. There's just two Google Earth images there from 2000 and 2020. And you can see that within 20 years, that red line shows the coastline in 2000. In 20 years, we've seen 250 meters of coastal retreat at this particular site. This salt marsh is eroding very, very rapidly. And you can see, you know, there's on the bottom right there, there's the effect of Storm Kira and Storm Dennis just last winter. You can see the blocks of the salt marsh just literally being eroded out and lost very rapidly. Whereas by contrast, other salt marshes, such as Tillingham in the Thames estuary, in a very, very similar coastal regime, have not retreated at all. They've not changed at all. And our project has been trying to understand, well, why has that been the case? And the evidence that we've found is that the reason that Wharton salt marsh is retreating so rapidly is because of its vegetation structure. You can see the surface of Wharton salt marsh is just a very, very thin cropped grass. That has a huge impact on the subsurface roots and the pore structures and the voids within the sediment underneath the vegetation. Whereas at Tinningham, we have a much richer, much more diverse structure of plants and vegetation above ground, which creates a much, much stronger network of roots that hold the sediment together below ground. Now, in this instance, one of the key factors here is that the difference between Tinningham salt marsh and Wharton salt marsh is that there's grazing on Wharton salt marsh. There's sheep and there are cattle that graze that salt marsh. And that brings me to the next form of geomorphology that Dennis Brunsden perhaps missed, which is the biological impact of geomorphology is one area, but now we can probably see the role of human-led geomorphology, what we refer to as anthropogeomorphology, having an even bigger impact on our physical environment. So in the example that you saw of Wharton, the impact has come from an indirect consequence of land use, of grazing, changing the vegetation structure, changing the sediment structure, changing its capacity to resist erosion. But we also see direct intervention on our landscape for our own purposes, for infrastructure, the legacy of ongoing mineral extraction and resource extraction. So you can see, the Bingham copper mine in Canada, you could drop Scawfell Pike into that hole and it would basically still not reach the land surface. We have large areas of our coasts, our rivers, are very, very heavily modified to maintain them for our benefit. And if any of you have traveled to places like Dubai and the United Arab Emirates, you can see large scale re-engineering of our coastline to suit tourism and leisure purposes. And it begs the question, is there such a thing as a truly natural landscape? Now, I love to take my students up to my favourite lecture theatre. This is the Low Sweden Bridge Lecture Theatre, just above the campus in Ambleside where I'm based. And on a sunny day like this, and we do get them in Cumbria, it's lovely just to take the students up and just to look at this landscape. And they're sketching the field landscape here of the central and northern fells, looking northwards up through to Grasmere and Rydal Water, looking at the mountains of the Central Lake District. But the question that I've asked them here is, what can you see here that's natural? The landscape of the Lake District is a destination for lots of geographical field trips and lots of university and school trips in pre-COVID times and hopefully post-COVID times to come. Visit this location as a fabulous area to go and witness geomorphology, to go and measure some of the properties, because it's seen as one of the wilderness areas of England. But if you rewind 3 years ago, the Lake District in 2019 was designated a UNESCO World Heritage Site, but it was designated a World Heritage Site on the basis of its cultural landscape. Almost none of what you can see in this scene in front of you is natural. Certainly the biological landscape is completely artificial. The whole of this scene should be covered by woodland, mixed woodland in the lowland areas, training to Caledonian woodland of mixed pine and birch woodland on the summits. And only the very, very highest summits, maybe the top 10 or 15 highest peaks of the Lake District, would be above the tree line in the present day. And it's because it's all been absolutely modified by human behavior. But what that means and I'll go into this in a bit more detail in a few more minutes, is that actually the processes that are operating, the geomorphological processes, those first order processes driven by physics, are also completely unnatural in the way that they're operating. And that brings me to kind of the heart of what this session is all about, which is this idea of the Anthropocene. The economist Paul Crutzen, who sadly died just earlier this year, just last month, was an economist and political scientist who worked with a chemist, Will Steffen, who I'll be talking about quite a lot in the next 10 minutes. And Steffen and Crutzen defined together this idea that human impact on our planet is now reaching the stage whereby actually humans have left the natural envelope of the Holocene interglacial that we have been existing in the last 10,000 years. If you visualize our natural environment, our natural envelope that we're living within, as almost like a mixing bowl with a ball that's been placed in it. If you think that, over a period of time, we get natural variation in our environmental situation. But what Crutzen and Stefan suggested is that actually we've departed the natural envelope of variability that we see for the current interglacial period that we're in, and that we're now in unprecedented times. That quote, the Anthropocene is defined as being the current period of geological time in which humans and our societies have become a global geophysical force. Essentially, what Crutzen and Stefan have started in Train in 2003, when they first wrote together, and ongoing today, was this idea that we're now entering a new phase of Earth history that is completely different from anything that the planet has ever experienced before. Now, the concept of the Anthropocene is probably one that you've touched upon and you've heard a little bit about. It still hasn't been formally designated as part of the geological column. It's just in the final stages of being designated and formally acknowledged by the International Commission on Stratigraphy to become the next formal stage of our geological history. So it's going to become, very soon, within the next year or so, a completely new geological period of time. Whether that's an epoch, like the Holocene was and the Pleistocene was before it, whether it's an era like the Cenozoic, so the last 65 million years, is still yet to be determined. And that's why I'm using the terms fairly carefully. But really what Stefan and Crutzen have suggested is that we're now entering unprecedented times. And there's been a lot of discussion about when we entered the Anthropocene. Now, the proposal that's been placed before the International Commission on Stratigraphy is that everything changed in 1950. We entered a period of time that was referred to by Paul Crutzen as the Great Acceleration. You can see this picked out in almost any measure of the planet. I've put up here, this is just an example from Will Stefan's paper that was published just last autumn, of a few socioeconomic trends: global population, water use, energy use, the use of telecommunications, GDP, all of the values that we measure when we're understanding social, economic, political, cultural development within the planet. And then next to it, I've just put some of the Earth system trends: the acceleration of greenhouse gases being emitted into the atmosphere, so the enrichment of carbon dioxide, change in temperature, loss of forest ecology, looking at changes to our coastal zone. And you can see that all of them change in 1950. It also coincides, one of the geological challenges of trying to record the Anthropocene is, what's the marker that marks this out? 1950 also coincides with the first large-scale thermonuclear tests operated by the United States and the Soviet Union, as was then. And that's left a global record of radioactive material across the Earth's surface, which is essentially the marker that will record the onset of the Anthropocene for hundreds of thousands of years to come. So what this means is something that's really unique, because putting these trends together shows us why geographers are so valuable at the moment, because what this is showing is the collision between human and physical geography. It's showing that the Earth system isn't just this physical structure, it's also the social, cultural, and economic structure. And it helps us to understand why the Anthropocene is so different, why the Anthropocene is so unprecedented, and why people like myself get so excited and interested about trying to understand what this means for us and for the planet. Because if you think, for the past 4.6 billion years, Earth history has been determined by science, by the unconscious laws of physics, the things that have changed Earth's orbit around the sun, the things that have changed plate tectonic processes. These are all forces which are unconscious and unintentional. Yet in 1950, we transition into something completely different. And that's really nicely illustrated by the Keeling curve here. The Keeling curve is the record first instigated by Charles Keeling from the Mauna Loa Observatory on Hawaii, that was just recording the concentration of carbon dioxide in the atmosphere continuously since just prior to 1960, so about 1955. Now, this shows a record of the changing concentration of carbon dioxide. But what it also shows is Where's that carbon dioxide come from? It's come from anthropogenic emissions of greenhouse gases. It's come from the result of conscious thought by humans. Suddenly, we're in a world where our history is no longer being governed by unconscious laws of physics. It's now conscious thought, decision-making, and volition, which are now changing our Earth system. So what we're seeing with something like the Keeling curve is an example that shows that our climate is changing. So our physical Earth surface structure is changing, which is going to change all the processes that operate on our planet, but it's changing because of social, economic, political, cultural factors. It's changing because of our decision making. And that fundamentally changes all of our understanding of how planet Earth operates. And that's for one of the main reasons why I think in many ways the approach we've taken to geomorphology up until now really has to change. We have to start thinking beyond these sorts of very traditional models of the Earth system. This is, probably again an idea that you may have seen in textbooks or papers on the Earth system. The idea that the Earth is kind of this interlinked series of spheres, the geosphere or the lithosphere, the solid Earth, the hydrosphere, the bit that's made of water, within which, of course, we've got the cryosphere, the frozen component. Then we have the atmosphere, the gaseous layers of the Earth above the solid part of the planet. And then we have the living component in the middle of it, the biosphere. If we look at this model of the Earth system, it's missing so many different components. It's good that it has the biosphere. It's good that we can see within this Earth system that there are connections between those spheres. And in my early years of teaching and at university level, I used to use this diagram a lot to say that if you put all of this together, this is essentially the climate system. The climate system draws together all of these ideas of the four spheres of the Earth. But that's no longer really true. And Will Stephan, who I've mentioned a couple of times already, he published a new model of the Earth system. And this is the diagram that you can see in front of you here. It's quite a mouthful to take on board, but it's actually a really, really key mechanism to understand how our Earth system has changed. So the first thing that Will Stephan does is he simplifies the physical sort of spheres of the Earth into two, the geosphere and the biosphere. What is happening within the physical component of the planet and the biological component of the planet. But then he adds a third sphere, the Anthroposphere, where he starts drawing in issues such as production, consumption, the idea that we have material fluxes, and even also things like inequality, poverty, development issues coming into this. What we're seeing here is an Earth system which is being driven by not only those physical unconscious systems, but is showing how our actions within the Anthroposphere now start interacting with that behavior of the Earth system. So how do we bring economy, society, culture within the Anthropocene into kind of an idea of Anthropocenic geomorphology? And there are numerous researchers that are doing this, but again, let's start off by looking at these large scale pictures. First of all, let's go back to that idea that the second proposition of Dennis Brunsden is the idea that there's a relationship between uplift driven by plate tectonics and denudation processes, the processes that wear down, erode and transport sediment elsewhere into the Earth system. Now, if you look at this diagram that's come from some of Bruce Wilkinson's work, published 15 years ago, what this shows is that humans are now far more effective at moving and eroding the landscape than any of our Earth surface processes. The natural underlying estimates of how much sediment is being eroded and transported within our Earth systems is about 7.2 billion tons per year. That's from the terrestrial land surface. Now, if we look back on that graph, you can see that probably about 400 or 500 years ago, humans started becoming more effective than those Earth surface processes that are shifting sediment around the planet. And that now, and if you look at those scales, they're both logarithmic scales, now we are moving an order of magnitude more sediment around the planet than all of our Earth systems put together. So that's all the glaciers, all the rivers, all the slopes, all the permafrost, everything that you can think of. If we put it all together, we are more than 10 times more effective at shaping our planet. And that's really what we think about in terms of that direct anthropogeomorphology. You saw those examples earlier on of the types of things that we do: coastal defences, river defences, all the structures that we put together. We are directly having a massive impact on our physical structure of the Earth system. But it also goes way beyond that direct anthropogeomorphology. It's much more pervasive than that. And the best way to think about this is to take two classic diagrams that talk about how landscapes emerge within catchments. Let's look at the Horton's runoff model, his idea of pathways of water through the catchment, and then Stanley Shum's ideas of how rivers behave. If we think about this, if we look at that left-hand diagram, this is the transport pathways, hill slope runoff pathways. Where does water go when it falls into a catchment? If we look at that, we can start off with precipitation. We have precipitation falling from the sky. That will get intercepted by vegetation. It will get infiltrated into soil layers. It will percolate down into bedrock and groundwater layers. It will move as runoff, through flow and underflow into our river systems. And that's a model that we can think of. We can scale down from global hydrology right the way down to local catchments. But let's think about that now in the context of the Anthropocene. First of all, the impact of human-induced climate change is changing how precipitation is being provided. So we have modified, particularly in the mid-latitudes. I'm seeing this today, looking out my window at the rainstorm that's falling on me at the moment. We're seeing, first of all, a change in the amount of precipitation that individual locations are getting. But also we're seeing a much more significant impact, which is in a more energetic climate system, we're getting more extreme events. So we're seeing, for example, lots of long-term drought events, followed by short-term bursts of intense precipitation. So we're fundamentally changing the way that water is being supplied to our landscape. Our interception is now fundamentally being changed by the way that we have shaped our catchments, by changing vegetation, by agriculture, by grazing, by all of those land use and land utilisation mechanisms. We're changing the degree to which our catchment will intercept water into the biological store. That's also then having an impact on infiltration. You know, one of the key challenges that a place like the Lake District is experiencing is dramatic soil erosion. You know, I estimated last year that we're looking at perhaps losing all of the soil from the high fells of the Lake District in the next 50 years. That soil is a really important medium for plant growth, but it's also the most important water store that we depend on for our water resources. And so as we plough, till, manage our soils and sediments, we start eroding those because we're getting more extreme events from precipitation. We're losing that soil store. We're changing our groundwater store because we are extracting water from that system. Then we get to the river itself. So eventually that water will flow to an open water channel store, what we call a river. Stanley Shum came out with this classic diagram that said that, you know, on the right hand side, that talked about the idea that we can understand channel geometry, channel form, as a function of gradient, the long profile of the river, but also the amount of water that's being supplied, the amount of sediment that's within the river system, and also what the riverbank materials are. And if we think about that in reality now, let's look at just one simple upland catchment in the Lake District. If we take, this is Stockgill, looking down from Kirkstone Pass down towards Windermere. If you look at that landscape overall, first of all, think about, where does the water go? Where's the interception storage? Remember, this landscape is naturally being covered in woodland right the way across this surface. There is woodland, but it's much, much sparser than it would be. That's partly because we've got these little vermin walking around the landscape, because we're grazing our landscape with sheep, with cattle, we're ploughing, we're tilling this land, we're changing the vegetation structure deliberately. So we're having an impact on biogeomorphology. Remember, I showed you that slide from earlier on from the salt marsh of the change in resilience of a salt marsh as a consequence of changing vegetation structure. What does the grazing of this catchment mean in terms of hill slope stability, slope movement, soil erosion, the erodibility of sediment into our river itself? Then when we start getting into our river, we start seeing that actually we regulate rivers. If you want to look at a map of the regulation of rivers in the UK, basically just a map, look at a map of rivers, because every river in the UK has got some sort of management and regulation scheme, whether it's something like this, which is a small hydroelectric power scheme, which ironically, has been put in as a green venture. It's fundamentally changing the behaviour of this particular catchment. What's happening here is we're drawing off water to drive a turbine. We return it later on within the catchment, but what we're doing is we're starving that system of water. Equally, by putting in things like weirs, locks, check dams as part of the legacy of the Industrial Revolution, what we're also doing is we're breaking the connectivity of our river systems. What you're seeing here, this is a weir near Staveley, again, just up near me. You can see that upstream of the river there, you can see still water environments. We're completely changing how water would flow within this river system. And then down from there, we're seeing much more active river flow. What's happening in this weir is that as we're getting still water conditions, we start getting sediment raining out. We're stopping the river doing what it would naturally be doing. And of course, what we tend to find as well is some students here trying to measure the hydrology of Scandale Beck, neighbouring Stockgill. You can see here that the river channel can't migrate. There's a really large wall there that's stopping and fixing the channel in place. And you go anywhere down in pretty much any river catchment and you will find channel stabilisation, stopping the river doing what it wants to do. All of those processes impact the way that those rivers behave. If we think that erosion of rock and pre-existing sediment, transportation within rivers, whether it's by air, whether it's by gravity, whether it's by ice, and the deposition of that material elsewhere within a catchment system, that is basically geomorphology. And what that means is that we're seeing a disconnection in the way that our systems operate compared to what we would expect from kind of classic textbook examples. And you can see here, the example on the left, this was an image that was shared on Twitter by Tara Valente, the local sort of regional sort of radio reporter up here, of the effect of Thirlmere Dam in the northern part of the Lake District. We've had a lot of snow recently here in Cumbria. When that snow melts, it's a very effective agent at flushing water and sediment into river systems. So you can see on the right-hand side there, the River Greeter is full of suspended sediment. But on the left-hand side there, you can see St John's Beck, absolutely clear. St John's Beck drains the flanks of Helvellyn, some of the highest fells in the Lake District. It should be full of sediment in exactly the same way that we see in the River Greeter. But it's not, it's clean, because there's a large dam, Thirlmere Dam, which is there to provide water for Manchester and the Lancashire lowlands, has essentially trapped all that sediment. And that means that we're changing the way that this river is operating and functioning. That will change its behaviour. We could use Stanley Shum's models and sort of say, well, there's something very different going on here. But also, we're doing something else. That right-hand side image is taken from a water sample, taken from Scandale Beck, that image that you just saw in the previous sample with my students in the water. This image is just looking at under the microscope at fibres of plastic, polyester, plastics which have come off from fleeces, from clothing, and have entered the watercourse. Now, Scandale Beck is a small upland catchment in the Lake District. It's, where we were is just as it enters where the first residential housing is in Ambleside. Yet the concentration of plastic fibres, we were finding that every second there were over 1,700 fibres of microplastic being transferred through that small river stream. We're suddenly now introducing a whole new range of materials to our geomorphological systems, and that has big impacts. And again, just to show you an example from my own research, we can see the role of plastic changing the way that sediment moves in larger Earth systems. This is an example from the port of Rotterdam. Rotterdam port is the largest container port in Europe. It has about a third of the European Union and UK's trade comes in and out of the region through this particular port. So it's a huge piece of human infrastructure. As a consequence, because it's in the Rhine estuary, as you can see from the NASA Landsat 5 image there on the left, Because it's in a river estuary, this is an area which will naturally be accumulating sediments. And you can see from the turbidity of the water in the photograph, it's carrying lots of silt, enough silt that you can see the plumes of sediment in the river estuary and the delta extending out into the North Sea. So because of that, the Port of Rotterdam authorities have to spend millions of euros every year dredging out the port to maintain the facilities, because as particularly with globalization, we're seeing ever increasing the size of container vessels using this landscape and operating within this area. So they have to maintain this river system. And they've found that the cost of dredging has increased. They actually spend a lot of money modeling the transport of sediment into Rotterdam harbour, and that's what the image is on the bottom right of the screen, is their model of where sediment will be accumulating. And they use that then to plan their dredging systems to start stripping out that sediment, take it out to sea, dump it out into the shallow marine environment. But we got involved with them a few years ago because they were saying, it's costing us far more than our models would predict to be able to dredge this landscape. We're actually spending 55 million euros extra a year on dredging, and that's a lot of money. And they don't know why, or they didn't know why. And so that we undertook some research to look at, well, what's happening with the sediments within there? And that little sort of funny, sort of irregular shaped object that you can see in the lower left is the cause of the problem. That is a flock. A flock is an aggregate of clays and silts stuck together with biological material, stuck together by the EPS, which is secreted by microbial action as it's kind of working and breaking down those clay particles. But you can see from this particular flock that you can see in this sample here that it's got lots of these big spars that stick out. Now those spars tend to be cyanobacteria, blue-green algae, that form the structure, the scaffold to which individual platelets of clay will adhere to and stick to and form this flock, which then as it gets bigger will eventually just settle out of the water column. But what we were finding in the Port of Rotterdam is actually the core of these flocks were actually those microplastic fibers. That what we're seeing now is the introduction of these novel materials, these plastics which we use every day in our lives, it forms most of our clothes, are now changing sediment dynamics. So that now what's happening is that we're creating these flocks much more rapidly. They're becoming bigger. They're settling out much more rapidly. So the waters of the Port of Rotterdam are filling up with sediment, bonding themselves to these flocks. So going back to Dennis Brunson's 10 Commandments, we're just coming to the end before I sort of open up, hopefully, for any questions that come out in the comments. Questions of, well, those are some of the direct processes. The two key factors that Dennis Brunson talked about that drove how landscapes and how geomorphology develops is tectonics and climate. Now, there's not a great deal that we can do to change tectonics, but we're all very, very aware, innately aware, of how much we're changing climate. And that as a consequence of the predictions of climate change, you can see the various scenarios there from the Intergovernmental Panel on Climate Change, forecasting what temperatures and what precipitation will be like between now and 2100 in terms of the changes. What you can see is there are going to be massive changes to the way that our Earth system functions. And that basically means that all of our Earth systems, whether we're talking about polar glaciers, whether we're talking about the glacier in Iceland, Solheimjökull, that you saw earlier on, all of the mechanisms that are driving the way that those glaciers operate, those Earth systems operate, are being driven by our activities. And so it means now that the whole of the Earth system is being directly and indirectly shaped by human activity. And whilst Dennis Brunson's 10 Commandments of geomorphology and what we learn at school and to a certain extent in university still are very valid, they're still a great way to understand those first order natural geomorphic processes, we now have to recognise the role of life and particularly of humans in changing that process. And we're seeing the impacts of that regularly. Here are just a selection of climate change driven stories in the BBC news media just last year, showing how glaciers, soil, groundwater, catchment hydrology, wildfires, all of these processes, these natural processes would operate in a normal, natural geomorphological system, are now being completely driven by Anthropocene processes. So to pull this to a close, we need to look at the Earth system in a different way than maybe we have done previously. We need to recognize that, first of all, geomorphology still matters. Understanding the processes that shape landscapes is critical, and it's probably becoming even more critical as we go into the Anthropocene, because the effect of humans on the Earth system is becoming more apparent. It's becoming a much more front of mind issue. So we still need to understand that geomorphology, that traditional approach to geomorphology, but we have to add to that geomorphology has to incorporate production, consumption, waste management, driven by cultures, values, economies, societies. And then, in fact, geomorphology in the Anthropocene is no longer at the core of physical geography. It really should be right at the heart of geography as a discipline. And, of course, we just have to remind ourselves that geomorphology unlocks the wonder and the fascination that we can all take from looking at our surroundings and just asking, well, how and why does this landscape look like this? And the answer, of course, to all of that is because of its geography. So thank you very much indeed. I hope you found that interesting and a useful session. I'd just like to invite Aaron, I think, to come back in. I think you're chairing this little bit here in terms of if there's any questions from the panels and from everybody watching.
Yeah, thanks a lot, Simon. Yeah, really, really interesting. I think we have one question, but before we get to that, I'll just give you a couple more seconds to ask any other questions if there are any. I'll just remind you again that that you can catch the full replay of this stream on the Geo website. It'll be in the past events section there. And also just a small announcement from us. I know there were some quite a lot of emails last term about whether students can sign up for these events, and I can say that this term they absolutely can. There's a student and a teacher sign up form, so yeah, everybody welcome to join these online lectures. Okay, so there was one question from Jack for you, Simon, that said, should we no longer refer to a landscape as natural, and what would the alternative be if so?
That's a really good question, Jack. Thank you for that. It's a really difficult one, isn't it? Because I think a lot of what we talk about within geography as a discipline is talking about what do we mean by nature. I moved to Cumbria a few years ago because I wanted to be in an environment which felt a lot more natural. But of course, looking at this landscape, this is the view from Gummers How, just in the south of the Lake District, looking right the way across the panorama from Langdale and Helvellyn. Almost all of that landscape is a human landscape. The geological structure is there, and that's something that is a relict of processes that operated 10, 15,000 years ago and beyond. But actually, the majority of what we can see that's active within that landscape there today is not natural. But then, we then have to start thinking about those ideas of, well, how do we separate nature from culture? How do we separate these thoughts and ideas? And really, I think what we define as natural, what we define as landscape, is really what we each individually regard as that. We all look at this landscape in a different way. I look at this landscape as something that's very calm and very restive. Other people might find this landscape threatening or difficult to work within. So it is a really difficult context in terms of saying, well, what do we mean by natural? So yeah, really good question, Jack. Thank you.
Okay, yeah, we've got a couple more. I'll just read them out. So this one from Susie. When you say that humans are the key driver in geomorphology in terms of rates of denudation, etc., are you mainly referring to the unintentional effects of changes that we make to the river systems, climates, etc.?
Again, really good question, Susie. Thank you. I think the answer is yes and no. So first of all, I think if we look at the absolute volume of erosion and sediment transport that humans undertake, direct anthropogeomorphology, so road building, house building, the building of infrastructure, coastal defences, all the various things that we extract from our landscape, on their own, they now contribute more in terms of sediment movement on the surface of the planet than any of those natural river systems, glaciers, etc., would contribute. But then on top of that, we then have to factor in that unintentional stage, which is the fact that particularly because we've shaped climate and because we've shaped the way that catchments behave, we've got that indirect impact on sediment transport. And as far as I know, nobody's really been able to quantify that. Now, how much has the indirect impact of humans on the processes within catchment changed and shaped the way that sediment is moved around? Now, we often talk about geomorphology in terms of what we call the sediment yield, how much stuff is being moved around by the planet. So the short answer is absolutely, our direct interventions are already more important, but the unintentional effects are unquantified.
Okay, great. I think we've just got a couple more that we can do before we finish. So from Brooke, Simon, do you think in the context of teaching geomorphology in a secondary that a change terminology within the curriculum, following on from Jack's question on perceptions?
Hi, Brooke. Brooke's a recent graduate from Cumbria who's gone into teaching, so it's nice to see you sitting in here. Yeah, I think one of the main reasons for giving this talk is to get teachers and students to start thinking differently about geomorphology. Geomorphology is still taught within this very, very traditional framework. And I think that's a real shame, because I think it misses out on the fact that geomorphology as a subject underpins so much of what we're dealing with here. What we're seeing, hopefully what has come out from within this talk, is that we're seeing the impacts of economy, society, development, inequality, poverty. All of these concepts and ideas can be explored through the lens of the landscape.
Okay, there's still coming these questions. Another one from Nebula Kid. I've heard a lot of people using the start of the Industrial Revolution as the beginning of the Anthropocene. Would you say that the 1950s / the start of the Great Acceleration is more significant than this?
Yes, again, that's a good question on the Anthropocene. It's one of the questions that's been debated quite intensely ever since Paul Crutzen and Will Steffen proposed the idea back in 2003. For geologists, for stratigraphers that look at the deep time in Earth history, there are key things that are required to be able to say whether you've got a marker that changes us from one geological state to another. And one of the key mechanisms is that we have to have something that is a universal marker, something that is recorded extensively across the planet, and a marker that is recorded in terms of a consistent signal that will be a long-term recorded marker. Now, the Industrial Revolution marks the start of that acceleration, but of course the Industrial Revolution transgresses time. You think in the UK and Belgium and Northwest Europe entered the Industrial Revolution 150 years before parts of Africa, Asia. In fact, some parts of Africa have never entered the industrial age. They've gone into a post-industrial age directly from being pre-industrial. So there's been a lot of discussion about whether we've entered the Anthropocene in the Industrial Revolution, the 1950s. There have been arguments that actually the Anthropocene began 8,000 years ago with the onset of agriculture. There's been a lot of work that's been looking at saying that the changes to vegetation structure, and particularly in river lowlands and the release of methane during early onset of agriculture, actually fundamentally changed the Earth system there. But all of those are very difficult to say, well, where's the golden spike that you could put into a sequence and see here is where something has happened across the whole of the planet that shows this change. And that's why the onset of nuclear testing, which coincides with that great acceleration, has been used as that marker for the Anthropocene.
Great. Okay, I think last question, and then we'll have to call it a day because we are nearly out of time. So this one's from Anthony. Do you think it would be worth allocating a lesson to students regarding the superimposing of landscapes and the mirage of seemingly natural landscapes?
Absolutely. I think that's a fabulous idea. I think that we have this sense, and I think we see it reinforced right the way through school and in a lot of university courses, that we have this kind of dichotomy between human geography and physical geography. But actually, I think this idea of looking at the landscape makes, it forces us to look at this and recognize that actually they're all palimpsests. Every single landscape has got a sequence of different things that are superimposed on top of one another. I was looking for a nice schematic diagram that could sort of, show how those layers are put together. I couldn't find one. I was sitting there thinking, right, there's an opportunity there to draw something that could be used in teaching of this, because I think you're absolutely right that we need to get people to recognize that you look out at the landscape here in the Lake District in that view that you can see, and sort of see that there's this amazing level of complexity, there's this amazing level of interactions taking place, and that by trying to physically separate them into geomorphology, biogeography, social development and land use is a very, very artificial structure. I think for teaching, we often do need to put them into discrete units so that we can kind of break them down into sizable chunks. But I think it's a really good idea, Anthony. I think it's a fabulous thought.
Brilliant. All right. Well, I think that's that. So thank you everybody for attending. Thanks all for your questions. That was really great to see so many people with lots of interesting questions. So thanks again to you, Simon. And
thank you very much.
Hopefully see some of you again next time.